This is what your calculator looks like. It's got pretty much most of the features that you'll find in the regular Desmos. But let's take a look really quickly at how you can answer many questions using the graphing calculator. Okay, so the first type of question is what we see right here, where you're just solving for an expression 8x minus 1. And like I said, it's easier to solve it by hand, but if you're going to use a calculator, what you will do is you'll write the equation on the left side, or the left side of the equation in one line, and you'll write the right side of the equation in a second line. Okay, and what that's going to do is it's going to create, and you always need to use x's and y's for this. So even if they give you a different variable, use x and y. And so here's the left side of the equation written. I'm then going to go to the next line down, and I'm going to write the equation for the right side. Now, anytime it's just a single variable, you need to write the y equals part to the equation. So y equals -6 is going to give you that equation. Okay, now, you can zoom in and out on your graph here, but where these lines intersect is going to be the solution point, and you'll be able to see that solution point. So here, what I see is my answer is -2.875 and -6. Now, it's not asking me for this solution point. And the Desmos calculator is usually giving you answers in decimal form. You can always find the fraction form of it. I'll show you how to do that in just a moment. Okay, but notice this problem is asking you to solve 8x minus 1. So if this is your x value, what you can then do is just type 8 times this number, -2.875, minus 1. Okay, and it gives you your solution, -24, and that is your answer. Now, there's another way that you can evaluate this if you don't want to type it in right here. Okay, and that is, you can give it a different variable. So you can say 8a minus 1, and then you can designate what the a is equal to. If the a is equal to -2.875, it will evaluate that now for you. Okay, so that would be your other option, but just entering the number is something that you might as well do. All right. I'm going to show you this next one here to the right, and then I'm going to have you try the remaining two on this slide on your own. Okay, so we can go ahead and clear this. Okay, anytime you need to adjust the window settings here, you can zoom in or out on it. If you need to get bigger adjustments, if you go into the settings up here, you can change where that's giving you. So if I want to just go between -10 and +10 on the x's and the y's, and that just kind of narrows it in for me. But let's say I need to see something that's in the 100s or in the 1000s. I can go in here and I can adjust it, the settings as well. All right, so let's take a look at this next equation. Notice this next equation has other variables in it. Okay, you can include those other variables, but every time you include one of the variables, it creates a slider on the calculator. And we'll talk about that here in just a second. So here's the left side of my equation. When it gives you the prompt for add sliders, I'm just hitting enter and it'll add both of those for me. I'll come back and talk about what we can do with those. And then the right side of the equation, 5 minus 9x. Notice it gives me my two equations. See how these are color coded? Okay, so my black equation is for this line up here. My purple equation is for this line. If I want to hide one of them, I can just toggle the graphs on and off. The points that are always labeled and that you see here are the intercepts. So if you click on the intercepts for this purple line, notice I have my y-intercept, I have my x-intercept, and then I have the intersection of the lines. If I click on this black line, this first line, I have my y-intercept, my line's intersection point, and my x-intercept. So those are the sort of critical points that are shown on your graphs. Right, so notice this question is asking you, where does this have infinitely many solutions? Okay, what's the value of a and b? So notice my a's are going to be -9 or 9. So what I want to do is I want to test these numbers on a for -9 and 9. Now I can either use the slider to do it. I can go in here and I can test -9. Okay, or I can actually change my settings. Oops. My settings are -9 to 9, and now my slider is at the very far left, very far right. I can see the two different things. Now notice when my black graph has a value of -9, these graphs are going to intersect, right? Since it's asking me infinitely many solutions, I want these graphs to be exactly the same. They need to overlap each other. Okay, so again, as I'm looking at this, I need to change my b values to either be -31, +31, -41, or +41. So I'm going to just click on the settings. I'm going to change -41 all the way to +41. And let's just test these. So if I just go in and I test the different options here, or I'll just start at the beginning. So I can either type it or slide it. When I type -9 and -31, notice they intersect. They're not the exact same line. So I can cross that off my list and move to the next one. I'm going to check the next one where it's a -9 and a -41. So again, if I use my slider here, those also intersect. I need them to be exactly the same, so that's not it either. So I do know that I have to test a 9. Notice 9 and -41 do not intersect. So I slide this here as I move through. 9 and -31 do not intersect, so I keep sliding it. 9 and +31. Notice they're overlapping now, right? If I look, these are the same line. So that is my solution. So my option here, by searching the different possibilities, I see that +9 and +31. So it allows me to test the numbers from the answer choices if I have the multiple variables. Okay. Now, once again, we've already talked about how to answer these questions like mathematically. All I'm doing on these slides is showing you how you can solve it with the calculator, the desmosA calculator, okay, which is again going to be included on your digital SATs starting in March. Okay, I want you to try the bottom two questions. See if you can answer those two questions. All right. So again, using the calculator for this next question is not the most efficient way. Okay. But if you are setting it up and solving it, if we write our equation on the left side of the equal sign, and we write a second equation for the right side, okay, notice here, we want to find what x plus 3. Well, we need to see where these intersect. I'm going to scroll out. I see that they intersect way up here. Okay, and when I click on it, I just have to click on one of the lines to sort of highlight it, and it shows me the intersection. You don't have to like zoom in. We know that our answer is 31,204. So that's our x value. Okay? But it's not asking us for x, right? It's asking us for x plus 3. Notice 31 is an answer choice. I guarantee they're going to have those distractors on the SAT. Okay? So if you solve this and you say 31 and you see that it's one of the answer choices, this will be a very commonly missed option. Make sure you read carefully. It's asking us to take 31 plus 3, which is 34, and that's the actual answer. Okay? Now, notice my graph now is at a level that I don't necessarily want it to be, like this big. I can either zoom back in, or if I just go to my settings, I'm going to highlight this and just turn it into -10 to 10 for my lower limit of -10, positive, or upper limit of 10, and that gives me my sort of general window view for that. Okay, so the last question here, if I type in my equations, the left side of my equation, I can go to the bottom. My right side is just an integer, so I do need y equals. If I don't put a y equals there, it's not going to give me anything. And once again, I can see that I have to zoom out to see where these intersect. I highlight one of these lines and it'll show me the intersection point, 113, -4. Here, my question is asking me to find x. X is 113, and so that is my solution. All right. So this is setting equations where you can, like again, if you had the solve feature of a TI-89, you can also kind of use that to solve for these, but this is how you'd use desmos for that. All right. The second thing that I want to talk about is that desmos has this built-in regression equation, or this regression calculator that allows you to solve for, oops, let me set this up real quick. It allows you to find what equations, or to find the equation of a line given a set of points. Okay? And so all you need generally are 2 points, for, especially here for a linear equation. Okay? If you can plot 2 points, you can create the equation of a line for that. Now, notice on this problem, it's asking us to find the slope, and it gives you 2 intersections or 2 points. If we plot those 2 points in our table, and so here, this little plus button right here allows you to create a table on your desmos calculator. And if you just type in the x and y coordinate, so -2 is the x coordinate, 0 is the corresponding y coordinate, you can just keep scrolling over or down and over to get to the next row. Your other point is 0 and 94/9. Just leave it as the fraction. So we've entered our 2 points. You can write an equation for this by typing the following. Okay? If you hit y1, again, you have to label it with that subscript. And instead of writing equals, use the similarity symbol. This tilde, this squiggle mark. It's shift, and then it's the key right next to the left of 1. If you write that and then slope, which is represented by m, the one, just type 1, it'll subscript it for you. And then type x1, and then plus b. What do you notice here? This is y equals mx plus b, right? It's the equation of a line. And once you choose that, what you can see is it gives you your slope and your y-intercept down here. So our slope for this is 5.22. And now you just need to find which of these numbers is approximately 5.22. You don't have to test every single one, right? You can figure out which ones make sense. Okay? 5, the fact that it's a 5 means that the number in the numerator has to be bigger. So I can eliminate those 2. I don't even need to test those 2. Okay? And so now I'm testing 112/9 if I wanted to. 112/9, it gives me 12.44. That's not it. So I test 47/9. That one is 5.22. That's what I was looking for. Okay. All right. So I'm going to leave this up as you are working, but I want you to see if you can answer those remaining 2 questions on this slide. Okay. Following the same example of, this is called a linear regression. It's creating a line. We'll go to the right and then down because that's sort of the bottom one is the harder one. All right, so if we solve this next equation right here, you're given 2 points and you want to find the equation of that line. Now, if you were doing this by hand, what I would encourage and hope that you can see is, since you know the y-intercept right here, 0, 1, you know that the only 2 possibilities for this would be this equation or this equation, right? Those are the only 2 that where the slope-intercept form has the y-intercept of +1. And so you already know that you have like a 50-50 chance of getting that right, hopefully. But let's take a look at how we would do it on a calculator if we wanted to. We'd create our table, so plus and then choose table. Enter our coordinates. 0, 1 is one of them. 1, -7 is the other. We can then write our equation. y1 is similar to, or again, that calls up the regression equation, m times x1 plus b. So here is your set of answers. So your slope is -8, your y-intercept is 1, so you can see your answer has to be slope of -8, y-intercept of +1. So this one is like the direct, although again, you can answer it without the calculator as well. All right. This next one is can be a little bit more challenging. Okay, so here we do have a table again, so that we can set up our table, start plugging in our points: 26, 253, 35, 334, and 38, 361. Okay. We're told right here, this is a translation of a line. So the line tells us it's a linear equation. So y1, similar to call on the regression, mx1 plus b. Now notice, the way that I've written this right here, this is the equation for the points in that table. But it's not asking us to find the x-intercept of the line in this table. This is line H. It wants line K. Well, line K moves all of these values 4 units down. So 4 units down means we need to adjust which coordinate, the x or the y. The y needs to be 4 less, right? So what we can do is go into our table, and what we actually want is we want to decrease each of the y's by 4. Notice I'm just typing in -4. You can enter the calculation in there. Okay, and so this gives you your equation. So now this equation, the slope of 9 and a y-intercept of 15, y equals 9x plus 15. There's the equation of our line. Okay, and so what we now want to do is we want to find which of these points is going to be on that line. Okay, and so notice what we have right here. The y values are 0. And so we can use the calculator for this, but it's probably just as easy to subtract 15 from both sides, divide by 9, and there's our x coordinate, our x value. 3 goes into 9, 3 times 3 goes into 15, 5, so you get -5/3 when y is 0. So at this point in time, it allows you to find your equation, use that equation to calculate which of those points would fall on that. Okay, now, when we are looking at this, we could have also, on this, we could have plotted each of these points. Okay, so if you're going to plot a set of points, what you can do is you can just type your coordinates. So -23, 0. And notice, here's my point. You can see on this, does it fall on that line? No. You can also click right here. You can see what your x-intercept is for that line as well. -1.67, that allows you to see that it's the -5.3. But you can also just continue to plot points. So if you wanted to test -19 over 9, 0, does that fall on the line? Nope. Go to the next one. Test -4/9, comma 0. Does that fall on the line? Nope. Go to the next one. -5/3, 0. Does that fall on the line? Yes, that is your point. So you can test it. You can search for it, find the intersection. Okay? Those are your options. Second question. How did I get that line? From this here, or from this one? So when you type this command right here, it takes all of the points from your plot from the table, and it puts it into an equation unless you're hiding it. All right, the last thing that I want to go through, again, I'll clear this. Okay, is like taking some linear functions. The desmos allows function notation. So you can represent y's as a y equals, but you can also represent it as f of x is equal to. Oops, I'm not doing functions yet, sorry. Let's look at these equations here, kind of just using the same thing, setting up some tables. So Let's say you were being asked to write the equation of a graph that's presented to you. Once again, you should be able to look at this graph. You see that the y-intercept is a 3. Notice it's telling you that this is the result when your f function is shifted 14 units up. So you would physically subtract 14 from this, and that would be your new y-intercept. Because all the y-intercepts are different, that's all you would actually need to solve this. But let's talk through how you would do it on this calculator. So what you would first do is you'd identify several points on here on this graph. So I have the point 0, 3. If I look at another set that I can see exactly where the point intersects on those grid markings, I have 5, 2. Once you establish 2 points, you're good, and you can write the equation from that. And so what I would do is set up my table using the points that I'm given, so 0, 3, and 5, 2. Go in, set up my equation. Y1 is similar to mx1 plus b. Gives me that the equation of my line here. Okay, and so here's where that falls. But this isn't the equation I want. This is f of x. Or sorry, this is taking my f of x function and shifting it up 14. So what I want to do is I want to actually find the equation of a line that where if you shift it up 14, you get to this number. So when I come to my y values, I'm not adding 14 to them, I'm subtracting 14. So if I subtract 14 from each of the points, it then gives me the equation of this line, which again, if I want to view it, I can view it down here. This shows me my y-intercept, -11, so I know the only option that has the y-intercept of -11 is this first one. But I can also look here, a y-intercept of -11, slope of -0.2, which is a -1/5, and so it confirms that that is the equation that I was looking for. All right, so try these last 2 questions here and here. See if you can find that using the linear regression. Let's take a look at these last 2 questions here. Okay, so the first one here, you want to come up with the equation that represents this data. So we go in, we create a table, okay, and let's put our numbers in. Right, we use our regression equation, y1 similar to mx1 plus b. That gives us our equation, and we're looking at 2.2 minus 4. Again, when you look at your answer choices, the only answer choice that has a y-intercept of -4 is this. If you ever want to see whether a fraction has a specific decimal value, there's 2 things you can kind of do here. One, if you wanted to confirm that 11 over 5 is 2.2, you can either take 11.5 and then test it, or you can do it the opposite. You can take the decimal form, and notice right here on the right side, or sorry, on the left side, it has this little fraction bar form. If you click it, it'll put the rational form of that decimal. Okay, so you can convert a decimal into rational form by clicking this button, toggling it back and forth. Okay. All right, the final question here. It's asking you to find the slope of the line. Now again, there is a calculation for slope, right? This question is just asking you, can you calculate the slope? Difference of the y's over the difference of corresponding x's. That's all great if you don't remember that, or if you would just rather plug it in to a table. All you need is 2 points, and you have that. So 15 and -15, and then 1 and -12. This gives you your 2 points, y1 similar to mx1 plus b. And here's your slope is this m value. Now, notice on this, if you enter this so I copied and pasted it into a separate line. Okay, you can enter your answer as a decimal, okay, on your SAT. So when you have those fill-in questions, you could enter your answer here as -0.214. Okay. Now, if we look at this and try the fraction form, if you get a fraction, if you get a rational form that doesn't seem reasonable, if it doesn't fit within like 3 or 4 digits, don't use it. Okay? Just use the decimal form, and you're good on that. Okay? Like I said, if you were calculating this with the calculation, you can get a fraction form of this where 0.214 is approximately the right answer, but you can enter your answers as decimals on the SAT.